Mazes are pretty cool. There is something special in that tedious process of starting at one side of the paper and then having to find a valid way to the other. After what feels like ages of suffering, you finally look back and see that cool line, serving as a memoir for all the nerves you lost in the process. Anyways, let's automate that process. And later in the video, we will be solving the biggest maze that could fit on the screen, so stay tuned. But before we do that, we need a few things. Like, for example, the actual mazes to solve. And they have to be tough too. So let's first use some pre-made ones and then later generate gigantic ones on our own. So in order to find some pre-made mazes, all we have to do is Google. And would you look at that, somebody already did the difficult job for us. Let's go with super tough mazes for computers of all ages. That should be a good starting point. But this brings us back to the question, how the hell are we even going to solve these? And the answer lies in one of my favorite algorithms, breadth first search, or BFS for short. Let's use this easy maze as an example for how it works. Each iteration, we are going to mark the current space as visited, and then move in every available direction. The moves will be handled with a queue, which means that the program will be moving in this diamond-like shape. This process of moving in every direction repeats until we either run out of moves, or in this case, we reach the exit. Before starting the algorithm, we have another problem. How are we going to represent these spaces? There are many ways to solve this, but the simplest one is to just treat every pixel as a space. Then make the black pixels walls and the white ones spaces. The goal is now to reach the first red pixel, which I put here. With all that being said, let's watch some maze solving. Whilst this process is simple and creates really cool looking results, it is very slow, mostly because I couldn't be bothered to optimize it. Just thought I would mention that. This montage actually took half an hour to record. Very cool, let's try another one, but this time let's double the playback speed. Now, let's generate some custom mazes and then solve them, as counterintuitive as that sounds. In order to do so, we will be using the recursive backtracking algorithm. Don't worry if it sounds complicated. It's actually really simple. After selecting the dimensions of our maze, we are going to start from the top right corner and then randomly choose a direction to move in. We repeat this process, keeping track of all the spaces we visited along the way, until we run out of available neighbors. When that happens, we retrace our steps and find a space that has a neighbor. This guarantees that all spaces will be visited. Afterwards, it's simply a matter of creating walls wherever there isn't a connection between two spaces. And now is the moment you have been waiting for. Let's create and solve the ultimate maze. 200 by 100 different spaces. Let's see it work. Now that we have created our puzzle, it's time to solve it. Amazing! Well, this is the part of the video where I ask you to like, comment and subscribe so I can keep making these. Until next time, peace!